Okay, so for this problem, we're going to talk about percentiles. So percentiles are literally just the percent that we're shading of the standard normal curve from left to right. So it says the deciles of any distribution are the values at the 10th, 20th, so on and so forth, 90th percentiles. So we're going up by a decile, which is just the number 10. The first and last deciles are the 10th and the 90th percentiles respectively. What are the first and last deciles of the standard normal distribution? So what it's asking is really, what are the z-scores of our standard normal curve when we're looking at deciles, or the 10th and the 90th percentile? So we can do it a couple different ways. So first, if I'm just looking at a graph, so I'm going to pull up a graph really fast. Maybe I'm going to pull up a graph. Okay, so here is our graph of the standard normal curve. And so what it's talking about here is the 10th, which is probably way down here, the 10th percent or percentile. And then if I go and shade in a different color all the way up to the 90th. So all of this here would be the 90th percentile. And so it wants to know exactly what is this z-score here and what is the z-score here. So the easiest way to do it would be to do it on our calculator. So I'm going to make a quick video to show us how to do it on our calculator, and that will be the fastest. So I'm going to move this over here, and I'm going to make a video that'll show how to find it, the z-scores in our calculator. Alright, so I'm going to play the video of how to do it in your calculator. Alright, so I'm going to show us how to find z-scores in our calculator when we are given a percentile or percentage or an area under the curve. So what we want to do is we want to hit the second button and the vars button. And that's going to put us to something called distribution. So we're going to do second, vars. Now all these different types of things come up, and eventually we'll learn what all of these are. But right now, we know that we're given the 10th percentile and the 90th percentile. So 1 and 2 actually give us percents. So if I have the z-score, I can plug it in here and get a percent. But inverse norm number 3 is what we want, because that says, okay, if I have a percentage, now I can get back a z-score. The area is also known as the percent under the curve, or the percentile. You have to put that in as a decimal. So we're talking about the 10% for the 10th percentile. And for standard normal curve, our mean is 0. That's mu, another way to say mean. And this is sigma, another way to say standard deviation. So I scroll down and I hit paste. So just paste it into my calculation area, and I hit enter. So it tells me that negative 1.28 is the z-score for the 10th percentile. Now for the 90th percentile, I do the exact same thing, or I can actually arrow up so that it's highlighted, hit enter. Now I've just copy and pasted it, so now I can just change my 10% to 90%, hit enter, and a positive 1.28 gives me the 90th percentile. So notice how those are basically just flip-flopped, right? And we had been talking about that before when we were doing some of the problems from last week. So that's how you find them on your calculator. Okay, now it says, for B, the heights of young women are approximately normal with a mean of 64.5 inches and standard deviation of 2.5 inches. What are the first and last deciles of this distribution? Show your work. So, one of the ways that we could do it, well, I always like to look at the standard normal curve and redraw it. So what I'm going to do with the standard normal curve that we already have, I'm actually going to put in what our information is there. So it tells us that the mean is 64.5. So remember, that lies in the middle. And now I'm going to do 64.5 plus 1 standard deviation, 2.5, which gives us the next number where 1 would be is actually 67. Plus another 2.5 gives us 69.5. Plus another 2.5 gives us 72. And now I'm going to work backwards, and I'm going to do 64.5 minus 2.5 to go to the left of the mean. So that gives me 62 here. And then minus 2.5, that gives me 59.5. And then minus another 2.5, and that gives me 57 as the last. So I know that in here, approximately what I should be getting for each one. Now, since it's negative 1.28 for the z-score, what I can do for B, and I'm going to do this in green. So what I can do for letter B is, since it says show your work, what they really want us to do is to solve it out. So for the 10th percentile, I can do, so I know that my z for the 10th percentile should be negative 1.28. And that's equal to, remember our, let me start over. We need the z-score formula, which is z equals our data point minus the mean divided by standard deviation. So we know the z is negative 1.28 for the 10th percentile. And then I don't know what the x value is. That's what we're looking for. So we want to know what our x is, but I do know what the mean is. The mean is 64.5 and the standard deviation is 2.5. And so now what I can do is work backwards. So remember that if we're dividing by 2.5, to undo divide, I'm actually going to multiply both sides by 2.5. So I'm going to multiply that negative 1.28 times 2.5. That's going to leave us with negative 3.2. And then on this side, I'm just left with x minus 64.5. And now to undo the minus 64.5, I do the opposite of minus, which is add. So I'm going to add 64.5 to both sides. So now x gives me 64.5 minus 3.2 gives us 61.3. All right, so that's for our 10th percentile. Now I'm going to do the exact same thing, except with the positive 1.28. So I'm just going to edit this in red, or like this pink color, to see what happens. So this is now actually going to be positive 1.28. Actually, I've changed my mind. I'm going to do it off to the side real quick. So we have 1.28 equals, same thing, right? We're still dealing with the same information, still don't know the x bar, or the data value. I know the x bar. So 1.28 times 2.5 should give us a positive 3.2. So now I'm there. So now the only difference is instead of subtracting 3.2, I'm now going to add it. Plus 64.5. So 64.5 plus 3.2 gives us 67.7. So my 10th percentile is this 61.3, and my 90th percentile is this 67.7. And if we look on our graph, on our standard normal curve, where negative 1.28 is. So here's where negative 1.28 is probably. And then positive 1.28 is around here. So look at how close I am, right? So that says it's close to 62, and that's right. And this says it's close to 67, and that's correct. So that's how you solve it mathematically. I hope that helps us, and I will see you this week.